Hey guys, this is Miss Keys. Sorry if my voice just sounded, I was putting the remote back down. But I'm going to go through the backside of the homework that is due on the 27th for A days, the 28th for B days. This is the quiz review for the Unit 1 quiz that is on each of those respective days. So hopefully if you're watching this is a good review for the quiz. But let's get started. So first we're going to start with an arithmetic sequence. So in an arithmetic sequence, the first term is 12, the second term is 8. I like to kind of see it visually. Second term is 8. Let's find the common difference. So we find the common difference by subtracting our second term from our first term or just figuring out the pattern. So I know that to get from 12 to 8, I'm going to need to subtract 4. So my common difference is going to be negative 4. A good way to double check that, 12 plus negative 4 gives me 8. So I know that my common difference works for the two terms that I am given, which is great. Next, I have to find the 15th term, which is a lot. So feel free to write it out if you want to. I think it takes a lot less effort if you're going to use your, what is the word I'm looking for? Oh, if you're going to use your formula, of course. So our formula is u to the n equals u sub 1 plus n minus 1 times d. So let's write out what we know. We know that the first term is 12. We know that our common difference is going to be negative 4, and we also know that the term that we're looking for is the 15th term. So let's plug that in. So U15 equals first term plus number of term that we're looking for minus 1 times our common difference. I did this math a long time ago, so if I did it wrong, I apologize, but this will give me 14 times negative 4, which is a negative 56. 12 minus 56 is a negative 44. So my 15th term is negative 44. So we got that just by using our formula. The next one says find the sum of the first 18 terms. So our formula for the sum, S sub n equals, let me look it up, n over 2 times 2 u1 times n, or plus n minus 1 times d. That's right. That looks right to me. Okay, we're going to go with that. So we know that our n in this case is the number of terms that we're summing together. So n is going to equal 18. Our first term is still the same. That's 12. And our common difference is still the same too, so that's negative 4. Can you see that way over there? D equals negative 4. I'm going to shift it back now. But just so we know D equals negative 4. So let's sub everything in. We have the sum of the first 18 terms equals 18 over 2 times 2 times our first term, which is 12, plus 18 minus 1, because that's the number of terms we're summing minus 1 times our common difference, which is going to be negative 4. Making sure to add that second set of parentheses because we need to multiply this entire part by our 18 over 2. I don't know about you, I just popped that right into my calculator and I got a negative 396. So we can talk about that if the arithmetic is wrong, but I'm feeling pretty good about that. So we have the sum of the first 18 terms is going to give us negative 396. So now we've solved our first part for arithmetic sequences. Remember, we have tutoring hours on Monday if you have any questions about that. But this is how you do the first set. So let's move on to geometric sequences and series. Make sure we can see that nice and clear. Good. So geometric sequences, remember, are when we are using multiplication or division to get from one term to the next. So I'm going to now find the common ratio, which is the number that we divided by. So to find the common ratio, I always take my second term divided by my first term. So I'm going to do 4.5 over 3. So 4.5 divided by 3 gives me a common ratio of 1.5. Let's double check to make sure that works. So if we want to make sure it works, we can check to see if we multiply by any term by our common ratio, we get that next sequential term. So if I took 4.5 times 1.5, that would give me 6.75. I will double check that really quickly on my calculator. So let's see, 1.5 times 4.5 does give me 6.75. So I'm feeling pretty good about that too. Good. So 2B asks me to find the sum of the first 8 terms. So the formula for the sum of a geometric sequence is obviously a little bit different. So we have the sum of the first number is U1 times Rn minus 1. Notice that the minus 1 is outside of our exponent, so it's minus 1 altogether, over R minus 1. Let's fill in what I know. I know that my n is going to be 8 because I'm looking for the sum of the first 8 terms. I know that my U1 is 3 because it tells me that literally right there. And I also know that my R is 1.5 because we found that in the one previous. So now I can just plug everything in. So the sum of the first 8 terms is going to equal 3 times 1.5 to the 8 minus 1 over R 1.5 minus 1. That's going to give me, assuming I did this right, I got 147.773. So hopefully that is what you guys got as well. I just popped that right into my calculator. Let's move on to 2C. So find the least value of n so that the sum is greater than 45,000. So this is one of those tricky ones where really the best thing you can do is pop it into your calculator. Again, if you need help with a graphing calculator, you can come in before school on Monday or Tuesday. And you can use the Inspires just to make sure that you know how to do this for our quiz on Monday or Tuesday. So let's figure out what we would have to type into the calculator. So once again, we have our sum formula up here. So that's what we would use. So we'd have to plug in everything except for our n, right? Because if we're going to do a table in our calculator, we want to make sure we see every possible value of n that it can be. So we want to leave that as it is so that the table doesn't just give us a constant, which it would be if we filled this in. So we want to keep our u1, which is 3, times 1.5. And remember, in our calculator, we're going to want to type it in as an x because that's what we recognize as our variable. So 3 times 1.5 to the x minus 1 over r minus 1, 1.5 minus 1. If you pop that into your calculator, remember that you're going to want to put it into your graphing part because that's where we're going to be able to get our table. So if you go to graph, and if it's not up, you hit tab, you can type in what we just did. I recommend doing it with a fraction bar in your numerator and denominator just because that makes it a little bit easier. 1.5 to the x minus 1 divided by 1.5 minus 1. Hit enter. It'll give you a graph. Hit Control T. I'm going to try and put my calculator underneath there so you can see it. Ooh, that's a glare. That's a glare. Is that better? Nope. All right, I'm going to hold up closer. Nope, nope. Oh, there we go. Sweet spot. Okay. So if we see, I am scrolling, and I'm going to look for something that's greater than 45,000. So still going, super exciting. All right, here, this is the breaking point. So you see how this one is 44,885? That's not greater than 45,000. But this next one is, right? 67,330.4 is greater than 45,000. So what I'm going to write on my paper is that when I get to my 23rd term, the sum of the first n numbers is greater than 45,000. So then I'm going to say, how do I want to write this? I would say that my 23rd term, when n equals 23, the sum of n is 67,334.4. So you can really write it any way you can. That's how I chose to write it, just because otherwise I'm not sure exactly what it asks, right? Because it says find the least value of n so that the sum is greater than 45,000. So I want to make sure to include my n and my sum because that's both of them. And also for IB, it's really helpful to learn how to write about math. So writing out what you're thinking whenever you can is the best way to cover your bases to get full credit, right? So this is something that I would write. So basically it's your 23rd term, and that term is 67,330.4. Why don't we use the one before? This one, the 44,885. That one's not greater than 45,000, right? I'm looking for the least value so that it is greater than 45,000. So we want to make sure that that number we're putting down is actually bigger than the one that we're doing. Good. So that was our last sequences and series problem. So now we're going to move into everyone's favorite, which is Pascal's triangle and binomial theorem. So luckily for us, 3A is a pretty easy question, right? So we look at this and it says write down the number of terms in this expression. So we know that our number of terms is always going to be our original exponent plus 1. So I know that there's going to be 4 plus 1, 5 terms in this expression. What's my way that I can double check if that's true? I can draw out Pascal's triangle, right, and get to the 4th row. So this is the 1st row, 2nd row, 3rd row, 1, 3, 3, 1. 4th row, 1, 4, 6, 4, 1. How many terms are in how many coefficients are in my 4th row? 1, 2, 3, 4, 5. I know that I'm right with my 5 terms. So I'm feeling pretty good about that. So next, I'm supposed to find the term in x squared. So we have 2 ways we can do this. What this means when it's asking if you can find the term in x squared is it wants you to write down the term where you have a variable expression that says x squared. So you can either just expand it to x squared, but if I look ahead, I see that the last problem says to fully expand the expression. So I'm going to do that, and then I'm going to go back and write my term in x squared that I wanted to do. So let me see. I'm going to write out my 5 blanks. 1, 2, 3, 4, 5. I'm going to write out my coefficients. 1, 4, 6, 4, 1. And then I'm going to get started. So let's see. We start with to the 4th power. I'm going to look at my first term first. So I'm going to write times 2 to the 4th. That's a 4. X to the 4 times 2 to the 3rd. X to the 3rd because I start with my original exponent and I'm counting down. 2 to the 2nd, x to the 2nd, 2 to the 1st, x to the 1st, and 2 to the 0, x to the 0. Good. So I'm feeling pretty good about that. I looked at my first term. Now I'm going to move on to my second term, which is a -1. This is the first one that we've seen where we're subtracting 1. So it's good to remember that my second term up here is equal to -1. So I'm going to plug that in. And this is where every time we have to use parentheses and exponents, I always say it's really important. Make sure you put your second term in parentheses. So we have -1 to the 4th, so I'm going to say -1. Remember here we start with to the 0 power. So we have -1 to the 0 power times -1 to the 1st power times -1 to the 2nd power times -1 to the 3rd power times -1 to the 4th power. So that's how this just worked out. So reminder, -1 needs to go inside parentheses, otherwise the negative's not going to count when we do our exponents. So now let's simplify. Remember, when we're simplifying, we want to bring down all of our x's and all of our blanks. So let me just write out the blanks. I'm going to bring down my x's now. So I have x to the 4th. Now I don't have to worry about that. X to the 3rd, don't have to worry about that. X to the 2nd, don't have to worry about that. X to the 1st, don't have to worry about that. And x to the 0. I'll bring that down, but as we know, anything to the 0 power is 1, so I really don't even need it. I'll probably just erase it at the end, but for argument's sake, I'm going to leave it in. Now I'm going to simplify. So -1 to the 0 is 1. 2 to the 4th is 2 times 2 times 2 times 2. That will give me 16. Also, sorry that you couldn't see that last little bit. 16. So 1 times 2 to the 4th, 16. -1 to the 0 is 1, so just 16. Good. Moving on, we have 4 times 2 to the 3rd times -1 to the 1st. So I know that this term is going to be negative, right? Because I have a -1 to the 1st. That means it's going to be negative. 4 times 2 to the 3rd. 2 to the 3rd is 8. 8 times 4 is 32. So far I have 16x to the 4th minus 32x cubed plus, this is good, -1 squared just equals 1. So this one I know is going to be a positive. 6 times 2 to the 2nd. 2 to the 2nd is 4. 6 times 4 is 24. Moving on to this one, I have 4 times 2 times -1 to the 3rd. -1 to the 3rd is going to be a negative. So I'm going to make sure I write that in over here. 4 times 2 is 8. There we go. This next one, 2 to the 0 is 1. That's good. Negative 1 to the 4th is also 1. So 1 times 1 times 1, that's just going to give me a 1. And a reminder that our x to the 0 also equals 1. So that's good to go. So I have it written out. I'm going to write it a little bit more nicely off to the side. So I'm going to say 16x to the 4th minus 32x to the 3rd plus 24x to the 2nd minus 8x plus 1. And this is my final full expansion. I think you guys can see that. Again, you don't have to rewrite it if you don't want to, but I think that would be really helpful. Good. So now let's go back to 3b. It says find the term in x second. I'm going to look down here. This is my x to the second term because it has an x to the second in it. So I'm just going to write it up here. My x to the second term is 24x to the second. So that's one of those where I actually would really like seeing that, and if it didn't even ask us to fully expand the expression, we could literally just write x to the second, and that means it would be good to go. So again, we just finished the backside of the homework. I hope this was a really good review for the quiz. Reminder, if you have any questions, please come talk to me or Miss Avra, and we will see you guys either on Monday or Tuesday. Bye.